Now I want to talk about the United States Air Force airship Grand Eagle. As much as I have talked about it already, there's far more to the veracity of its concept than just what's written in story. The airship and the book it occupies were conceived in the 1970s, with some projection as to what technologies both then and presumed in the future would allow in its capabilities. As of now, in 2024, I think it's worth understanding the comparison between what was predicted and what has come to pass, which is a great deal. In the world of Gary Allan Roos's A Game of Titans, the airship Grand Eagle is considered a prototype aircraft, designed, developed, built, and tested in secret, very much in the style of Area 51's secret projects. As the brainchild of in-story Air Force General Smalley, the Grand Eagle was conceived as the first of a new class of military airship that could patrol the far reaches of the Pacific, detect and monitor potential and emergent threats, and respond to those threats or other emergencies as Grand Eagle does in story. In essence, the Grand Eagle class of airships would conquer the tyranny of distance that would always dog the United States in its military mission of projecting power and protecting shipping lanes in the Pacific. What would take the Navy numerous bases and the United States several international agreements to accomplish, Smalley's airships could supposedly cover in and of themselves. I think this concept of military power projection via airships is a worthwhile study, from the strategic level down to the operations level, and even in some noteworthy details as to how a military force of airships would be useful. On the strategic level, stationing airships across the Pacific can, like in Smalley's conception, provide the benefits of a persistent military presence to monitor air and naval traffic and threats thereto, but also the benefits of a vessel that can redeploy itself in a way land bases cannot, especially in response to threats or emergencies occurring at the far ranges of detection, asset deployment, and weapons. Our POV character Brandon asks a question as to the vulnerability of airships in this role, and Smalley answers the question. Their vulnerability would be no greater than said land bases. The context that makes this significant is the fact that modern military bases, especially American bases abroad, protect themselves from attack with a variety of missile defenses, as well as host aircraft and vessels meant to protect them in addition to upholding security policy abroad. Analogous to said land-bound military bases, an airship as a military base could be conceived as a forward operating base for the craft and vessels that would perform the direct duties of patrol and surveillance in peacetime, as well as interception and interdiction in wartime. Depending on the capacity to hold and operate aircraft, watercraft, or air-deployed ground forces, and the capabilities of those military units, an airship could have the military power not just of an aircraft carrier, but one expanded in abilities closer to a full-fledged military land base. Everything short of landing a giant cargo aircraft, but there's a way around that limitation as well. Unlike a land military base, an airship military base would have the ability to maneuver itself either to get into closer range for better reconnaissance or deployment, or to avoid being accosted by unwelcome vessels and craft. Just like an airborne warning and control system aircraft, an airship so equipped can direct friendly aircraft and vessels to control the air, surface, and even the subsurface. As far as its deployable craft are capable, and as far as it can directly protect itself, such an airship can greatly increase the range of other military units and formations while keeping itself safe and outside the range of possible enemy engagement. Depending on specialization, numerous possible roles demand closer examination. Coming to the question of operations, at least two questions come to mind. How many airship vessels might serve the mission to cover the Pacific, versus how many can be taken out of service for maintenance at the same time? And second, in what manner might the airships be serviced? These are not pedantic questions. Even the mightiest, most durable, and longest-serving vessels, like American nuclear-powered aircraft carriers, need to periodically come off of deployment to be serviced, inspected, and refitted, and the crews rotated off of duty, recuperated, and new crew tuned and onboarded into their new jobs. As powerful, capable, and survivable as Grand Eagle is portrayed, it can't cover the entire Pacific Ocean all by itself. It would need to be joined by several other vessels, both similar in its abilities, but also dedicated to supporting its service, like how warships need to be fueled via supporting oilers, as an example. I can imagine in Smalley's, or rather Roos's, conception, the Pacific would be divided into sectors, sized such that one or more airships can reach a station or destination within a given time period, so then you'd have a starting number of vessels. Then to account for deployment cycles. That is the time a vessel needs to take out of deployment to address maintenance, both routine and unexpected, as well as make ready to take on a new crew being trained for the new deployment. For everything a vessel and crew need pre-deployment, dedicated military facilities are needed. This brings us to that uniquely designed hangar from which Grand Eagle starts its maiden flight. Part of its secret development included the secret development of its hangar facility, which as a novelty in itself is dug into the ground, helping maintain an inconspicuous exterior and keeping away bad weather. While the facility in story is well concealed and well protected from prying eyes, some of that would have to be sacrificed for the accessibility needed to move in material and personnel needed for the service. So new hangar facilities wouldn't be kept as remote as in the desert. Really, the most important component of the Grand Eagle's first hangar that could be replicated would be its mooring towers that hold the airship steady while being docked inside or launched outside the hangar. Other than that, it might be a bit too expensive to dig massive concrete-lined pits everywhere an airship would need to be serviced. At the risk of sounding old-fashioned, my enthusiasm for airships notwithstanding, mooring circles where airships connect to a tower, are rotated from the tail using a railcar, and rolled into the hangar would be a perfectly viable means of securing airships not on deployment. It simply takes the kind of investment in machines and professional ground crews that goes into securing naval vessels to docks in a port. It's a mode of operation that's very different from how the Air Force operates compared to the Navy. Take landing, for example. In the Air Force, landing an airplane is usually a one-person job. No one else is in control except in between the landing and later takeoff. But for a vessel, whether water or airship, docking is a multi-person job, involving both the onboard crew and a ground crew to secure the vessel. If we dare to innovate, we might consider making structures to shield landing areas from adverse wind conditions, the way harbors shield vessels from adverse wave and tide conditions, or use dedicated airborne tugboats that can safely place airships onto their docks even in adverse weather conditions. Mission readiness and deployment cycles extends also to the airship's onboard aircraft as well. The full-size combat aircraft, the utility shuttle aircraft, the remotely piloted vehicles, and by extension drones as well, depending on reusability. Part of an aircraft carrier's usefulness is the ability to service aircraft in between sorties, individual aircraft launches, such that all the hours an aircraft needs to spend being maintained for every hour it flies can be fulfilled while on deployment. Such a capacity to maintain aircraft while on deployment is a mainstay of American supercarriers as it stands. As to whether an airship such as Grand Eagle could do it is another question. Having fewer full-size aircraft aboard certainly helps reduce the requirements for maintenance between sorties, so long as the lack of capacity is not a problem. The alternative to maintaining aircraft while on deployment is to sortie aircraft as often as needed while underway, but periodically dropping them off at a friendly base to receive a new batch of aircraft, while the first batch gets the proper maintenance. How often a carrier airship needs to come and switch out its onboard aircraft would figure into how many airships are needed to cover for mission needs. Otherwise, we should hope a Grand Eagle type airship might have a good stock of replacement parts and ideally futuristic and technologically useful repair equipment, and not just for the onboard aircraft either. As for an airship on deployment, a couple of important considerations that get neglected in story that real-life vessels must continuously address are the monitoring and inspection of the vessel's integrity and balance, and the ability to repair any damage incurred mid-voyage. If you've listened to my previous books I've read involving characters running around on airships, you might remember how they address damage in a certain way, rappelling down airship sides to glue fabric patches to breaks in the skin. For the Grand Eagle and her crew, there's no obvious path for any crew member to reach a damaged area and apply a repair, much less address any of a number of different repairs required per different kinds of damage. It's a large reason why the Grand Eagle's survivability in combat, as much as in peaceful cruising, is largely dependent on avoiding and averting damage, and why the Grand Eagle, narratively speaking, must avoid lethal damage in story. Hence all the technologically advanced defensive weaponry and doctrines. A real airship underway, however, couldn't solely depend on anti-missile weapons and weather avoidance. There should be an expectation that damage of one sort or another is inevitable, and may need addressing when far away from a protected hangar. Remote monitoring by miniaturized sensors at various points around the airframe and in the gas envelopes is perfectly viable, especially today. Where we come up short is allowing a crew member to run up to a break and apply a patch. Vessels on the water can address similar damage, leaks in the hull, in a variety of ways. They can use bilge pumps to eject the water overboard, close off hatches and bulkheads to isolate the leak to a certain compartment. And if a crew has very specialized training, they can apply special patches, plug holes, to stop the water until the vessel can reach a dock or dry dock for more permanent repair. Without the compartmentalization and access thereto, none of these really apply to airships. You can't bilge pump air overboard for one, and without a way for crew to rappel down the outside of the airship skin, or inside or between the envelope gas bags, there'd be little recourse to address a puncture, then go back to base. It's not like any little pinprick will pop a whole airship like an overpressurized party balloon, but a mission, or even crew and passenger safety and survival, may depend that damage be addressed when there's no time to reach a repair facility. Despite a lack of technical expertise, even from airship operations past, and no current plans for damage mitigation included in any future pie-in-the-sky concepts, I personally expect we can incorporate technology to make up that difference. I've mentioned in the past that Lockheed Martin developed a SpiderBot, or self-propelled instruments for damage evaluation and repair, a device that has its two halves magnetically attaching together through an airship envelope and moves over that envelope to look for breaks in the skin and apply a patch. These would truly be useful in continuous monitoring and calling out any repair jobs too big for it to fix. I can easily imagine these robots not just on the outside skin, but also on the gas envelopes themselves, keeping the lifting gas and outside air as separate as possible. Another bit of technology that could help could take inspiration from real-life self-sealing fuel tanks, where a puncture in a gas tank has a lining that expands in response to the passing liquid, plugging the hole and stopping the leak, at least until it can be repaired. The equivalent for an airship's gas envelope might use a self-healing fabric. I'm not a materials engineer or scientist, so I'm not going to pretend to know how that would work, but that such a thing exists and works would go a long way to mitigating damage on an airship's voyage. Still, some repair jobs, like the rear propellers being shot off, will need human hands and heavy components to be moved to the damaged area for the repair. It would be ideal if the crew didn't have to fire up the utility helicopter every time part of the airship broke, while far away from a catwalk, companionway, or tunnel. This brings up something glossed over in the drawing of the airship Grand Eagle. We don't know what the frame structure looks like. An airship like the Grand Eagle couldn't be built like a non-rigid Goodyear blimp. For the superstructure spread throughout the hull, the frame would have to be a rigid type. I even expect if you took out the skin and gas bags, the structure would look almost bridge-like. Where I'm going with this is that there's an opportunity with our modern materials and structural engineering to incorporate both structural frame elements for the airship with passageways for crews to access that same structure. Imagine the keel of a ship, but that's also hollow for people to walk through and inspect the structure and connections. Accessing a frame, longeron, or stringer on an airship might in the future have a close analog to how a work crew accesses a structural element on a bridge or the outside of a building, rappelling and all. Now I'd like to touch on everyone's favorite subject concerning airships, fire. And don't jump to conclusions too quickly. Having airships inflated with helium is not enough. Despite the assurance that non-flammable helium will make Hindenburg-esque disasters a thing of the past, the truth is that fire hazards that affect airships, their development and adoption, have more factors involved than the lifting gas flammability. In the history of airships, of all the catastrophic accidents involving fire, plenty have occurred on helium-filled airships, and have involved more flammable components, such as gasoline-fueled engines. The infamous Hindenburg disaster had its fire traced through multiple modern investigations to the tendency of the skin to generate sparks under certain weather conditions, in concert with electrostatic buildup and insufficient electrical grounding and bonding, and the flammability of the fabric skin with its doping of iron oxide and aluminum-impregnated cellulose acetate butyrate, materials commonly involved with fire accidents of the period. Even though helium is non-flammable, it cannot make a good fire retardant. You cannot use the gas to smother flames if the gas immediately floats straight upward away from the fire. Without a confined vessel, helium can stream past a fire without slowing its burning. In that case, the only other methods are to deny fuel to any possible fire and keep everything below ignition voltage or temperature. That means using materials that are as non-flammable as possible, or at least as resistant to flame propagation as possible. That should give time for a real fire retardant to be utilized. Another consideration is preventing electrical sparks the way modern aircraft do, by electrically bonding all parts of an aircraft that can accumulate an electric charge and thus risk generating a voltage high enough for a discharge. This is especially important where avionics, electrical components, and fuel are placed on an aircraft. For an airship, the importance of this practice extends to the lifting gas envelopes and skin. Whether hydrogen or helium is involved, if the fabric envelope is compromised one way or another, the whole airship is compromised, no matter what. By electrically bonding the gas envelopes to the rest of the airship frame, no static charge can make a spark in places where hydrogen may escape into the open air, or where oxygen may leak into the gas bags. Another method I could imagine saving an airship from fire is similar to watertight bulkheads. Even if the lifting gas can't be as compartmentalized to the extent ships can for their empty spaces, it should be possible to divide the space by a kind of fabric firewall or fire partition that can prevent a fire hazard from taking out all gas bags or the rest of the airship. I bring up all this minutia of maintenance and operations considerations because it's just not enough for airships to look pretty. All the fanciest and most high-fidelity artist concepts have never equaled the importance of a proper knot on a line while sailing. As much as I'd like airships in fiction to have a similar weight and metatextual importance on par with sailing ships, spaceships, and airplanes, supposing an airship can only take the role of performance stage belies the fact that even the stage has a great deal going on behind the scenes, just like real-life vessels and anywhere of the sort that adventure stories can take place. Appreciating what goes on behind the scenes can only add value to those stories when what goes on builds off of and adds to the larger written world. The reasons not least of which because I too would want airships to be real and contribute to real-life adventure. If you're a kid or a kid at heart, Then here comes the fun part. Here we can talk about the toys. The airship Grand Eagle and its crew gets to play with missiles, lasers, and onboard aircraft, including uncrewed drones. As a start, missiles are standard fare, this being a post-World War II setting. No more masses of artillery and exploding shells to fill the air in air combat, and no more dropping bombs like an ungainly airplane for the Grand Eagle. In this age, precision guidance at range is the name of the game. You might have noticed that despite the advanced surveillance and radar technology of the airship, their thermal imaging system is still susceptible to being overwhelmed by the rising sun. That indicates this is the period in missile guidance where infrared homing and missile tracking is dependent on a strong heat source, in contrast to a cool background. Just like in period military fiction, spoofing a heat seeker by flares, flying into the sunlight, or diving to the surface to hide among the hot ground clutter would be standard fare in this story. It also comes up again when the airship-based fighters are chasing an enemy threatening the airship. The Grand Eagle could have loosed an anti-air missile, but with infrared tracking of the period, there would indeed be a real danger of it tracking the wrong target, destroying a friendly plane. The Grand Eagle's missile guidance and tracking system probably has more in common with a fighter plane than with a surface-to-air missile battery, what would use command guidance, and where identifying friends and foes for those missiles would be of paramount importance. Just like it is today. Since Grand Eagle already uses command guidance to guide anti-missiles against enemy missiles, it wouldn't really be conducive to drama if that same system allowed missiles to be freely used in the midst of friendly aircraft. I fully expect modernized systems could turn Grand Eagle into a flying SAM site, and a real menace at that. If modern SAM sites are already a major threat, one that flies free of terrain obstruction and clutter might be a true nemesis to airplanes. The one weapon in story that modern aircraft don't get to use yet are the lasers. There was a program to install and use a laser weapon from a specially modified 747 aircraft, the YAL-1, started in 2002, but scrapped in 2011. It was meant to take down theater-based tactical ballistic missiles. The laser weapons depicted in story aren't quite so long-ranged. Just like real-life laser weapons, it's hard to keep a laser focused through atmosphere. They're used at much closer range, use a great deal of energy, but very quickly destroy a target. Modern laser systems are becoming optimized to destroy enemy missiles, artillery shells, rockets, and drones. A modernized Grand Eagle would probably rely on its laser weapons to hard-kill missiles at close range, rather than anti-missile missiles. This means an airship so laser-equipped could defend itself without altering its ballast and airworthiness, for as long as there's electric power, and leave the airship more capacity for other payloads. In my opinion, the advanced technology that the Grand Eagle showcases, and can best be expanded on in real life, are the drones. In story, they're called remotely piloted vehicles, because they were directly controlled by operators on the airship itself. And drones would not do anything on their own except what was reliably programmed into their flight computers. Much of what is portrayed for the RPV's flight capabilities matches up with real-life examples that operated in the 1970s. Where they diverge is in the air combat. Contrary to how air combat would have to be executed using an uncrewed aircraft, in visual range with reliable awareness of the sky conditions and enemies, the technology to allow direct control in air combat would not be available at the time, and not until present day in real life. To control an uncrewed aircraft as if you were flying yourself is called first-person point-of-view flight, FPV, what is a staple of modern commercial and personal drone use, but truly far ahead of its time in the story's 1970s setting. For the BGM-34C RPVs to mount Sidewinder heat-seeker missiles and maneuver against enemy aircraft, each RPV would need its own camera to give a forward view of flight. radio receivers from which airship-based controllers can command the flight controls, and an onboard radar system that allows detection of other aircraft and helps line up the missiles to lock on and track targets before launch. The story doesn't make clear that the operators have a first-person view of their RPVs in flight. If we assume that the RPVs are themselves blind and dumb, and all the detection capability is centered on the airship, like a really smart person with sight manually guiding a group of blind persons, then operator control of the drones would have less to do with a view over the drone's nose, and likely more to do with an overview of the airspace, and directing the drones from that vantage point. Think of it as a top-down real-time tactics or strategy game. More to the point, in order for maneuvers and missile attacks to be occurring faster than human reflexes, controlling those drones that cannot do air combat themselves requires programming them with flight maneuvers and conditions of flight they can sense themselves, then feeding them data remotely as to target and threat positions and velocities. The programming takes over to calculate the fastest maneuvers to avoid threats and achieve a firing solution based on the weapons mounted, the Sidewinders. For example, the drone senses it's in a dive at high speed and medium power. The Grand Eagle feeds it data that a target is behind and also diving at high speed, threatening to destroy said drone. And the command to acquire a firing solution still stands. The drone then calculates a looping maneuver of highest rate and smallest turning circle, bringing the drone around behind the target and within the optimal firing envelope of the onboard Sidewinder missiles. Shutting off the engine might have been a manual command from Grand Eagle, or a calculation that falls within acceptable parameters for flight maneuvers to satisfy the command. Modern-day RPVs, and especially autonomous drones, have a great deal more technological capabilities to work with, and I think there are still more abilities to take advantage of. The first development I want to talk about is remote control, and just how remote an operator can be from their drone. When pre-programming a flight and mission plan is not good enough, the range with which an operator can control an uncrewed aerial vehicle can be very long range, by taking advantage of satellite communications. While Grand Eagle in story is probably limited in its RPV control range via line of sight, a modernized Grand Eagle would likely base and launch the kind of UAVs, like Global Hawks and Predators, that regularly uplink to satellites to maintain control with operators, either on board the airship or back in the mainland USA, just as it was and is done in real life. The limitation of controlling drones via satellite at such long distances, however, is that there is a noticeable lag between issuing a control command and seeing a response from the vehicle at the other end. That's because in real life, drones are based on land close to the theater of operations, and remote controllers on those bases get the UAVs airborne before handing control over to controllers from the mainland for the missions at hand. Having controllers be based literally closer to a drone's operations area via an airship would make Grand Eagle a more relevant military vessel and platform, especially where more timely and more local control is needed, such as in air combat. The most ideal solution for programming a drone to perform air combat is for the drone to recognize for itself that it's in air combat. In real life, DARPA, or the Defense Advanced Research Projects Agency, has been developing a program to essentially teach an artificial intelligence how to perform air combat maneuvers in full-size aircraft. The program is called ACE, or Air Combat Evolution. The skills that such a series of algorithms could learn from this program can transfer over to other uncrewed aerial vehicles and uphold their roles in future air combat missions. A more recent development is in the U.S. Air Force Skyborg program, which would combine UCAVs capable of carrying various military payloads with the advanced programming to coordinate multiple UCAVs and crewed aircraft to carry out various air combat missions together. What would have taken multiple flights of specialized aircraft to accomplish circa 1970s, ground attack aircraft for the targets, escort fighters for air superiority, electronic countermeasure and wild weasel fighters against surface missiles, and airborne warning and control radar aircraft, could in the future be accomplished by versatile drones, each of which would be smart enough to share information and divide tasks in response to threats, while also being a more acceptable loss when the danger is too great to risk a piloted aircraft otherwise. An airship like the Grand Eagle that can support such a force of aircraft would be a boon to an Air Force's mission. Even when the military drones in question are as small and unsophisticated as commercial-grade quadcopters, an airship like Grand Eagle can still turn them into potent tools of military power, and it's a power I'd like to illustrate now. Consider the military airship as a carrier for reconnaissance drones. With enough aircraft to sortie at once, a kind of sensor net can be set up over an area to watch for movements of aircraft, watercraft, and land vehicles. Mission surveillance and reconnaissance wouldn't be solely dependent on the airship's onboard radar and other similar systems, powerful as they could be. As each drone could be substantially smaller than a piloted craft, any enemy that tries to avoid detection by downing aircraft would have a much harder time blinding the sensors while being detected, forcing an enemy to either accept being detected and monitored or find a more circuitous route. An airship carrier for a sensor net also applies to the naval mission of anti-submarine warfare. Since submarines can be so deadly when undiscovered, but so vulnerable once found, drones that can deploy or be deployed as sonar sensors on the water to listen for and track the movements of submarines can utterly negate the stealth the subs so depend on. Just like in real life circa World War II, when K-class blimps escorted convoys in the Atlantic against U-boats, there was next to nothing the U-boats could do to approach ships and avoid detection, much less strike back. There was exactly one instance a U-boat took down a blimp, and it was the blimp that got itself too close. Depending on any drone's abilities to detect and intercept airborne threats, like incoming missiles or aircraft, an airship carrying drones can deploy them in defensive counter-air ops, or more simply, surrounding and protecting a military asset, the airship itself for one. This kind of maneuver with drones essentially bodyguarding friendly units would ideally have the drones able to keep up with said units, as in with higher speed aircraft, or for longer periods over slower vessels, vehicles, and personnel, and have the drones be both smart enough and fast enough to recognize and respond to incoming threats, and expendable enough to become acceptable as losses to protect the important assets. For drones so capable and so utilized, a carrier airship that can support them for any lack of endurance is ideal. If you can picture how swarms of bees attack predators, then you have a good idea how this particular swarm would work. As for striking targets, real-life UCAVs already have numerous tools and methods for finding, attacking, and destroying enemies on the ground. From predator drones firing laser-guided Hellfire missiles to quadcopters strapping on warheads and ramming their targets. The ability of an airship to help must be more particular in each case. Assuming an airship can defend itself or be defended properly, housing a mass of cheap, warhead-laden drones can give them a base from which to reach far behind enemy lines or into enemy territory and strike en masse. As of this writing, air defenses are not efficiently tuned to detect and destroy small and slow drones, and these particular bombers wouldn't stay together in one easily detectable formation once they've reached their targeting area. So the problem of air defense gets much harder, and the airship takes this problem far beyond the front line. I think there's some room for innovation where said drones are concerned. With a proper identification of enemy targets, we might turn the guidance of payloads onto targets over to command and control drones already surveying the target area, that would themselves autonomously direct the disposable drones to their targets. Alas, future air combat missions may call for drones or piloted aircraft that are too big to be stored in an airship's aircraft hangar. but an airship would still be a useful asset to those missions. In real life, when a military aircraft need to fly further and don't have the payload to dedicate to extra fuel, refueling aircraft are called on to extend their range and time in the mission area. As indicated in the book, an airship, even a fast one, can't really go faster than the slowest modern jets can fly. Despite Gary Allen Roos writing that only VTOL aircraft can be docked on an airship, I expect non-VTOL aircraft can be hangared or at least docked if the proper arresting gear is used to catch them, and can be released for takeoff if released from a great enough height or catapulted. I'd like to think that in addition to refueling aircraft, an airship that docks aircraft, even without putting them in the hangar, could potentially arm or rearm them in flight, something that can't yet be done in midair. The only truly difficult operation I can think of for an airship would be the ability to accept and transfer large cargo loads, especially when transport aircraft can't be docked. To drop off cargo the way a transport aircraft would a base, but without landing, would probably need a combination of parachute extraction low-velocity airdrop and a Fulton surface-to-air recovery system, assuming helicopters lack the capacity. This would be a difficult operation for an airship because to accept new loads, an airship would need to drop ballast and increase lift, vice versa for offloading cargo. An airship's ability to act as a transfer point for material would depend on its capacity to recover ballast or buoyancy with each transfer. If getting material to where it's needed and fast is considered a relay race, then an airship with the design to efficiently control its buoyancy would be a uniquely versatile asset, even if such an airship were forced to specialize in that role. There's one more theoretical role for an airship I'd like to highlight. I don't know if anyone else in military-industrial circles has thought of this either, but it requires the advanced development of another technology yet to go mainstream: power beaming. Power beaming involves using a laser or similar device to transfer usable energy to a collector across open air without a physical connection. In this case, said connector would be a photovoltaic array channeling electric power to an electric-powered drone. An airship with excess power and a power beaming device could then sustain drone flight for much, much longer than could be done with docking, refueling, and launching. This whole section on outlining theoretical missions for a militarized airship has more to do with expanding horizons rather than outlining hard and fast rules for future development. It also has to do with countering the common and easy refrain that airships can't be militarily useful, we have planes for that. At the risk of beating a straw man, a pet peeve of mine, saying we can't use an airship the same way as airplanes or other vehicles and vessels misses the point I'm trying to make. Airships shouldn't be used the same way. It's like saying our modern warships are bad because they can't go broadside to broadside with a classic World War II battleship or even a sailing ship of the line. They're not supposed to. And if a story is trying to convince you that the heroes are worth rooting for because their military standing and military assets allow them to do heroic things, then it's worth considering the many different ways an airship can be a part of a hero's arsenal.